Dude, and then we start talking about infinity and calculus.
We're not talking about infinity.
Dude, let's talk about infinity.
So, my name is Sol Kim. I am the president for this year, and
I'm Blake, and I'm the secretary. You guys are stuck with me.
Sweet. So this is the first kind of video that we're doing to be posted on the YouTube channel, just in these pandemic times. Maybe you guys can learn something from it. Maybe not. So.
Or just hate us for doing math during the break.
Yeah, true. So, Blake.
Yeah.
Do you know what we're doing today?
You told me before this, and I sure hope it's not what we're actually doing.
Well, it is.
Oh, frick.
Today, we're going to prove that for any integer a, that a times 0 is 0.
Yeah.
That seems very trivial, I know, but
it's stupid.
Yeah.
Stupid.
I believe in you. Blake. You
No,
can do it.
I don't believe in me.
So the first thing we're going to do is we're going to define some stuff. So basically, I'm going to set up a ring. Now, rings like
a wedding ring?
What? No, not a wedding.
Oh, okay.
Like a number ring.
Oh,
yeah.
Okay.
So like there are groups, rings, and fields, but we're only going to talk about rings because that's a little more complicated. You guys can look up the specifications if you want to, but basically I'm going to set up a ring of only the integers.
Or you can read an analysis book. I mean, either one's fine. Yeah.
So basically, we're going to only define the integers. You know what integers are, right?
Yeah, it's like a whole number.
Yeah, but there could also be negative, right?
Yeah.
So,
but negative whole numbers.
Yeah, so I'm going to define two operations, right? Two operations.
Yeah.
For the integers, right? They're going to be addition and multiplication. That is it.
Already.
So that's all you can use.
Already.
So basically, some properties of the integers. So first of all, there's associativity. If I could spell, that's why I'm MAO president, not English club president.
We're here for math, not for spelling.
So first of all, associativity. This basically says, you know what this says, right? Like A plus B plus C is equal to A plus B.
Yeah, the parentheses property.
Yeah, the parentheses property. I mean, this is, and you can say the same thing for like multiplication, right? This is the same thing. Oh, frick. Wait, that's not it. Okay. God, thank goodness erasers are a thing. So, and like A, B, wait, why is it different?
That's fine.
It's a brush. Is equal to A times BC, right?
Yeah.
So, okay, so we know associativity. Now, there's another thing called commutativity, right?
Mm-hmm.
Yeah, that's it. And this basically says this thing's true. A plus B is B plus A. Or A times B is B times A, right?
Yeah.
So, and then finally we have distributivity.
Yeah.
So this basically says that this is equal to AB plus AC. Okay? And then we also have a few more properties that the integers enjoy. So first, there's a 0, right? And it basically says that for all, this symbol means for all integers that are an element of, for all a that are an element of z, or the integers, there exists 0 such that a plus 0 is a. Wow. That's so cool,
I
right?
know.
So, and then there's also one more thing, or two more things. So there's negatives, right?
We just took something so easy and made it sound so complicated.
Yeah, I know. It basically just says that a plus 0 is a. And like, this is a given rule. You don't have to prove this. Don't worry. We're not there yet.
Oh, well, so, not yet, but later.
So like, the other thing I want to do is define negatives. So this basically says that for all a that are a part of the integers, and this symbol means there exists x that are also in the integers, such that, I'll just abbreviate it as st, a plus x is 0. Can you guess what x is? just like
Is
through
it
your
is it
advanced
is
math.
it negative a?
Yeah, it
Oh
is,
my
but we're
goodness.
not going to call it that. We're going to
Okay.
call it x. And then there's finally 1. So basically, this means that for all a that are a part of the integers, there exists 1 such that a times 1 is a.
Oh, cool.
And this is all you're given.
Ah, frick.
So, given this, how do we delete everything?
Wait, don't delete it.
Oh, you need these, right?
Yeah,
Okay,
I need them.
So
I'm gonna forget to use them.
these are the only things you can use.
Ah,
Okay.
crap.
So basically, how do we zoom out? I probably should have thought this through.
Probably should have.
That's okay. There
Oh,
we
crap.
go. And then I'm just going to make this like really big. So now you have like all the room in the world just to prove that a times 0 is 0.
Alrighty.
Alright, so
Alrighty.
I'm going to, I'll write unless you want to.
I don't care.
Okay. Prove a times 0 is 0
Alrighty.
for all a is an elements of the integers.
So I'm gonna use my amazing ACT reading skills where I got a 23.
Alright.
And so I'm gonna use some deduction. Alrighty. You gave me some very specific things to deal with. Alrighty. You said A is an element of Z. I feel like I have to use that somewhere. Oh, this is not a good start.
Oh, we're only talking about the integers, so
Yeah.
So like, yeah, everything's an integer. And I'm not saying the reason why I'm not saying for like any real number, right, is because
that's stupid.
That takes a while.
Yeah.
We don't even know what rational numbers are yet, technically.
Yeah.
So we're only going through the integers right now. So what do you think?
Alrighty, let's see what all we have to work with here. So we got negative zeros, 1. I would like to start with the distributive property.
Okay.
That's probably completely wrong because a times. Actually.
Since we're talking about 0, I'll give you a hint. Why don't you start with the 0 property? Or the negatives property?
Dude, I was thinking about that.
Okay. Use the negatives property.
Negatives. So we say A is an element of Z, and then X is an element of Z as well, such that X is less than 0.
X, yeah. Okay.
What if we broke A apart?
Interesting. Into?
What if we made it into 2A plus X?
How do you know that's a thing?
Because you said that 4A plus X is equal to 0, so then that means 2A plus X would equal A.
Well, yeah, but how do you know you can add A to both sides of the equation?
What do you mean?
Like...
No, it's the same thing.
Oh, no. Yeah, I know. Like, everyone knows.
Yeah.
Like, this basically means that, right?
Yeah.
Just by adding A on both sides, right?
Yeah.
How do you know you can do that?
No, we already know. We already know that we already have an A, alright? And we know that A plus X is equal to 0. So if we know that, oh, I see what you're saying.
Okay, well, how do I know? So we know that A. Well, how do we know what A plus A is?
We don't. That's the point. But if it,
you know what?
Oh, you're saying L. Okay, never mind.
And you know what 0 plus A is by the 0 property, but how do you know what A plus A is? Can we definitely say it's 2 plus A? Or 2A?
I mean, yeah.
You know what, Blake, I'll cut you some slack. We're going to let 2A be 2A plus X, okay? So this is the first step in our proof. We're going to say that 2A plus X times 0 is 0.
Holy
okay,
shoot. We're already off to a bad start.
Yeah, what's the next step? And this is by substitution.
Yeah. Oh wait, you didn't give me substitution. Oh dang,
well,
this is a horrible start.
You can do substitution anyway. That's like a given property.
Next,
Do you know where to go?
I want to use the associative property.
Okay.
Or wait, no, not this use. The distribution property.
Okay.
And then we say 2A0 is equal to, 2A0 plus X times 0 equals 0.
Okay. What does that prove? And this is by distribution.
Right? That proves that that's a thing. Yeah.
Okay, what do we get out of this?
We get more things to deal with.
Yeah, now you have to prove that 2a times 0 is 0.
Oh gosh, I don't know if I know what I'm doing here. Alright, let's see what else we have to work with. We got the commutative property. Can we do anything with that? Probably not yet. What if I want to bring the x times 0 over to the other side?
Can you do that?
I don't know. Can I?
By
substitution?
Wait,
not substitution, by subtraction?
I mean, yes, because you know that, well, okay. So if we add negative x times 0 on both sides, right? We know that negative x times 0 plus x times 0 is 0, right? By the negatives property.
Or do we know that? Because we don't know that a times 0 is equal to 0.
Well, no, I'm talking about strictly x.
Oh, yeah.
So, oh, right. I probably should mention.
Oh, I should probably mention 11 minutes later.
Such that x, a plus x is 0, right?
Yeah.
Okay. So, yeah. What now?
I kind of want to bring the x over.
Okay.
The x times 0.
So, 3. 2a times 0 plus x times 0 minus x times 0 is equal to 0 minus x times 0, right?
Yeah.
That is what you're saying.
Yeah.
This is by substitution.
Dude, your presence sitting over here like, what the heck is this boy doing?
Yeah, I'm honestly a bit confused, but
that's okay.
I'll just go with it, you know?
Yeah, we don't know what we're doing.
So 4. Okay, so what are you gonna do with this?
Can I say that's equal to 0?
Can you?
Can I? Actually, let's do.
Actually, I think you can.
Yeah, okay.
Because this is basically a number, right? And this is basically negative that number.
Yeah.
So we can say that this is 0 by the negatives property, right?
Alrighty.
And we know that this is going to be negative x times 0 by the
shouldn't it
0 property.
Shouldn't it be 0 minus that?
What? Wait. No. I got rid of the 0. So it's just negative. Oh, wait. Yeah. It's just negative x times 0.
Okay.
Okay, cool.
Yeah.
So this is by negatives property, right? Negatives. And we kind of skipped a step. I'm giving you a little bit of leeway. And 0 property. Okay. Now what?
Alrighty. I want. Okay. Let's see what else you have to work with for a second. Right now we got. So we've used negatives property. Ones property. That's where I want to go next.
Huh? Are you just trying to like go through every single property?
Yeah. You gave me these properties for a very specific reason.
You don't have to use all of them. They're just there. They define the integers.
This is why I got a 23 on the ACT reading.
This is math.
This is math. Dude, I was taught use everything you're given, and it's failing me right now.
Yeah.
Alrighty,
maybe not.
But nah. But I do want to factor out as. Can I do that? Wait, yes I can.
Factor out 0?
Associative property. Wait, no, that's not associative.
Distributive property.
Yeah.
Right.
Reverse distributive.
Yeah, the converse of.
Yes.
So basically, from what? From this?
Yeah.
So you want to do this is what I'm seeing, right?
Yeah.
Well, how do you know what this is going to be?
Can
you even do that? You can't, right?
Can I?
Because you don't know what 0 times a is. You can't distribute stuff.
Alright, let's make that a sub 2.
Okay. And this is by the distributive property.
Where a sub 2 is some other number. That's an element of z.
Okay.
Frick.
Such that.
Oh, this is horrible.
This is horrible.
Oh my gosh. I'm making a mess here. Holy cow.
I'll give you until 15 minutes.
Okay. Oh wait,
that's 30
seconds.
30 more seconds.
Alrighty, speedrun time. Alrighty. Let's say frick. Alrighty, so we know 0 is going to be equal to 0 by the identity property. Let's say, but we know that they're equal to each other. Can I say that 2a plus a sub 2 equals negative x?
Can you say that?
Can I? Probably not.
No, because we don't know about unique factorization. And you can't divide by 0 anyway.
We don't know that.
Yeah, you do.
We do? But we don't know that a times 0 is equal to 0?
Well, we can't even divide. And technically what you're doing is dividing. So
yeah,
we don't know how to divide. Yeah. Alright, that's 15 minutes, Blake.
Yeah.
How
close was that? How close was that?
Honestly, not. But that's okay.
That's spectacular.
Yeah, no, this is a very trivial thing, right?
Yeah.
And like no one okay, like maybe if you go into like an introductory number theory course, you're
like
I did.
Yeah.
Unfortunately.
Yeah.
Then you're going to be expected to be able to do this, or at least from what they teach you. Obviously, you haven't like gotten familiar with the axioms enough to be able to do this kind of stuff.
I don't know what you're saying, but
the axioms are like the stuff that I gave you at the top.
Oh yeah, those the parameters.
So, prove that a times 0 is 0 for all a is an element of the integers. So, the first step. So we're gonna examine this expression, or actually, you know what? Control Z. Okay, so we're going to use the property of this, right? Such that B is an element of Z. X is an element of Z of the integers, right? We can say this, right? Because, and this is by the negatives property. Right? So we can substitute this into a times b. Wait, honestly, I forgot how the proof went. Okay, so we'll figure this out together.
This is awkward.
We'll figure this out together. So
I feel like this is exactly what I was saying before we started this. And then you were like, that's not how you do it. And I got sad.
What?
What?
No. I mean...
Not this part. Not that part. The part before we started recording, where I was kind of using my brain.
Oh, okay.
What little I have left.
So, this is by substitution, right?
How did we get the A?
Oh, it's from here, right?
Oh, I see. Okay.
Yeah. Good. So we're basically just oh wait, this isn't equal to 0 per se, but yeah, this isn't equal to 0. So we're going to be examining this expression right here. So we know that b plus x is 0, right? And we also know that internally we know that x is negative b, right?
Yeah.
So oh my gosh, there's just this black line from me trying to scroll through the pages.
It's going further.
Anyway, yeah. So by the distributive property, we can say that this is a times b plus x is equal to ab plus ax, right? Cool. So this is by distribution. Distributive property. Okay, next step. Wait, if you could scroll down. Thank you. So, now what? Well, we know that this is a, b, plus, well, this is going to be negative ab, right? Because we know that
x is negative
we
b.
know that x is negative b, right?
Yeah.
So we know this is true, right? And this is just by substitution. We let x be negative b, and by the negatives property, a plus b plus negative ab is 0.
Sweet.
And there's our proof. QED. Yeah, so, and to wrap it all together, right, to wrap it all up, we can say that a times 0 is equal to ab plus negative ab, which is equal to 0, right? So a times 0 is 0.
That's pretty cool.
Yeah. But like, when are you gonna ever use this?
Never, absolutely.
That's unimportant.
Dude.
Alright. Well, I hope you had fun, Blake.
You know what? I had a lot. This is. I could have gotten here eventually.
I'll make sure to get a different victim next time. How does that sound? Maybe it'll be you. I don't know.
If you take any of the other officers, they'll actually be able to do this. It's not as fun.
No. Maybe it'll be like a club member. Like, yeah, like another club member, not an officer.
Don't do it to the poor freshman.
No, I'm not gonna do it to the freshman. Maybe. All right. Well, I hope you guys enjoyed this very trivial seeming proof. It is trivial because we take this for granted, right? We take all these rules for granted. So yeah,
I don't think we take it for granted. I think this is worthless.
Okay,
well, I'm just kidding.
I mean, but this is like how math was built upon. This is like the foundation of math.
Yeah, 8 times 0 equals 0.
Yeah, it actually is.
Yeah.
That's really sad, but
Next time we should prove that you can't divide by 0. That'd be fun.
You know what? We don't even know if division exists. So we're gonna prove division next time. Alright, I hope you guys enjoyed that. And it's a bit long, but yeah. See you guys maybe like next week during the school year. I'm not sure.
If there's a school year.
Alright, bye guys.